Unit tests are great, but how do you test your data access? You sure don't want to actually delete records when you're testing the delete method, yet you definitely want to make sure that that method is configured properly. This is the type of problem that stops a lot of developers from creating unit tests. In this video, I'm going to show you how to overcome these obstacles in order to write tests that handle working with external dependencies like databases. Now, if you're new to this channel, my name is Tim Corey, and it's my goal to make learning C# easier. This channel is full of videos explaining the various parts of C#. I also have a website where I provide full courses on C# and SQL. You can check it out at iamtimcorey.com. That is also where a blog post for this video is located. It includes source code for my sample application, both at the start of this video as well as at the end. Also note that in the description below, you can find links to join a mailing list or support me on Patreon. Okay, let's get started in our example project. Now, this application is a bit larger in scope than some of my sample applications. That is because I wanted to give it a bit of a real-world feel. What we have here is a working console application that reads from and writes to s.o.l.i.d database. It uses AutoFact to handle the dependency injection. Now, covering these two topics is outside the scope of this video, but you can find videos on each of these on this channel. You can also find a full course on s.o.l.i.d on our website. Now, the last piece of configuration this project has in it is a XUnit project. And that's where we have our unit tests. So let's go right to the XUnit project called mock demo tests. So in here we have a folder called logic, which corresponds to this logic folder here. And we're testing the person processor, which there's the person processor right here. And this is the person processor tests class. Now, one of the things you might notice is these green check marks next to everything. This is what's called live unit testing. And this is only in Visual Studio Enterprise Edition. So if you don't have this, I'm sorry, it's a really cool feature. I debated turning it on or not for this video because I don't like to demo things that you might not have access to or you have to pay for. However, in this case, I think it adds a visual element to what we're doing. So I'm going to leave it on for this video, but just note that while you may not have these green check marks here, yours will still run. The difference is that when I make a change live, it will update these tests. For you, what you have to do is go to Test Explorer and either run all or click this little box here that says Run Tests After Build, which I recommend that, by the way. Now, what we have here is just 3 actual tests. Now, I've got 3 inline data statements here. I've got a couple more here, and then I've got 4 more here. So it's 9 total tests, which the Test Explorer verifies for us. So I'm going to leave that closed because it just takes up real estate. But what I have is I'm testing the convert height text to inches method, passing in various height texts. And then I'm also testing the create person successfully method and the create person throws an exception method. So both the it should work and the it's not going to work. And these are pretty standard tests. And if you go to a person processor, you will see that I'm covering the green check marks, by the way, denote coverage. So I'm covering this create person method, the constructor, and I'm covering the convert height text to inches. Now, a couple of things here. First of all, this is a tuple, which if you are in, I'm using .NET 4.7, and so this tuple is built in. However, if you're using an earlier version of .NET, then what you need to do is you need to install a NuGet package for value tuple. That's the name of the NuGet package. So you went to your references, right-clicked, manage NuGet package, and you browsed for value tuple. All one word. There you go. You install that package if you're using a version earlier than .NET 4.7. You can tell that by going to your properties of any of your projects and looking at the target framework here, and that's 4.7. Now, if you don't have 4.7, but you do have Visual Studio 2017, you can install these. So if they didn't come with your Visual Studio, you can install them later. They're download packages. Just Google for the .NET framework version, target framework version. Okay, and I recommend doing 4.7 just because you get some nice new features. If you want to go with 4.7.2, that's great. I didn't with this. I just went to 4.7 just so I could use tuples. But take every one of your projects to that same level. So 4.7 for demo library, and then also for my mock demo tests project. So all three are at 4.7. All right. The other thing I want to note is that, well, a couple things. First of all, for all three of these, I'm creating a new instance of person processor in order to test it. However, person processor, if you remember, takes in one dependency, the s.o.l.i.d data access dependency. And so it assigns that to an internal variable. However, the create person method, as well as the convert height to inches method, do not use that underscore database dependency. So therefore, when I create that instance, I pass in null for that instance. Okay, so I don't need it. So I just pass in null. That works, and it will go right through. Now, if I tried to use that underscore database for something in one of the methods that I call, that would crash the application. But because I don't need it for these tests, I can pass in null. It's fast, it's safe, it works. And actually, if it started crashing your unit test, that means you did something different. Like you brought in the underscore database into one of those methods and you didn't realize it. And that's okay that it crashes your unit tests or breaks them, because that means that you've changed something. You need to clean it up. So that's okay. Okay. Now, the other thing I want to point out is the code coverage. So let's come down here and let's comment out this line right here. And if we come back to person processor, right there, validate name. Notice how this line right here, line 117, has a dash and it says covered by 0 tests. So this code coverage is really helpful. Now, if you don't have Visual Studio Enterprise, that's okay. There are third-party plugins as well that do this. If you can get your hands on, legally, get your hands on Enterprise Edition of Visual Studio and do some testing, this is a nice feature to have, because it shows you right away, hey, you got a problem here. And in this case, I had written these tests and hadn't done this last test here. And the test is to pass in nothing for a first name. And by doing so, it says, oops, that output is false. However, since I commented it out, it's no longer being checked by any of my test methods. So just pointing that out, that there's a lot to be said for code coverage and making sure that your tests are covering all the different scenarios. Now, the rest of this application, we don't really need to care about. Now, just so you know, the console UI does run. It does go, there's no test for it. It does go through and it creates an application and it actually runs and it says, okay, what do you want to do? Do you want to display the people, add people, or something else? And so it does work. There's the actual database. So if you run this, it would run. In fact, let's just do that real quick just to show that, in fact, it does do something. If I load people, nothing comes back because there are no people. Okay. And now if I say exit and I hit return, it closes out. So this application does run, it does work, and it does write to an actual database. Now it's just the demo database, and it does write to the bin directory. So if you did a rebuild solution, it would clean out that database and start it over. All right, so that's the application. That's what it does. It does work, like I said. This is a demo project, demo library. We're not going to cover everything it does because the real point here is not to worry about the application. The application is great and it works, woohoo. That's not the point. The point is to focus in on this person processor because we have a problem. And that problem is represented by these three methods. Load people, save person, update person. Well, these three do exactly what they say they're going to do. The first one loads people from the database. The next one saves a person to the database. And the final one updates an existing person in the database. These methods are really simple. We don't do a whole lot in here, but we still want to test to make sure that what we're doing is what we intend to do. The problem is that if I test this method, save person, and I test it with an actual database connection, then I'll be saving a new person to the database every time. Now, a solution you may come up with is, well, what if we create a sample database? And then the unit test just wrote to that instead. And that could work. The problem with that is a couple things. First of all, you have to keep a database in sync, meaning if you change a table in the production database, you have to change in the unit test database. Next, you have to have some sort of cleanup script going on because if you're always saving people, that database is going to get huge. Especially in my instance, the live unit tests. The live unit tests run anytime that I make a change. Well, if I make lots of changes, I'm writing tons of records to the database. Now, what if we had delete? Now, I don't have one here, but what if we had a delete person method? Well, if that ran more often than the save person, then we might accidentally wipe out the entire database and all of a sudden the load people method would start failing because it's not loading any people. There's no people in there. So that'd be a problem. So it's caused these cascade problems if you're trying to write to and read from a real database. So what we're going to do is a thing called mocking. M-O-C-K. Mock. And what a mock does is it basically pretends like it's something that it's not. In this case, we're going to pretend like we're the database. Okay, so we have this dependency in this class on an s.o.l.i.d data access class. Now, the really cool thing about dependency inversion and using dependency injection to help you with that is that you don't have hard dependencies, or you shouldn't have in most cases. And so with no hard dependencies, or very few, then you don't have to pass in the real s.o.l.i.d data access class. You can pass in your own. You can create a separate one, a different one. And what happens here is by passing in a different one, you can say, yeah, don't actually write to the database. Now you see me do this. When I create a demo project, I might have a save data method, but it just has a console write line, and that's it. And so it's pretending like it saves the database, but it doesn't actually do it. That's the kind of class you can create and then pass in to the constructor of person processor instead of the real one. And that's what we're going to do. But if we had to write a whole new class that implemented this interface, that'd be a pain. And it would make our mock demo test class a whole lot bigger. Because now all of a sudden we're replicating every single instance where we're passing it around. So we're going to do mocking, which pretends like we have a full object when we don't really need that full object. So we'll get to that in just a minute. Now, the other thing I want to point out, because I want to make sure that I don't gloss over this or have you see something and then not realize what we're doing here. That is a dependency on the person model. We're not passing it in through the constructor. And so you may wonder, well, why are you doing that? Why do you have this dependency? And the reason why is because this is a model. And this just holds data. It doesn't have data and processing. And so because of that, I feel comfortable instantiating a new object just for data. And so that's okay. It doesn't violate, or not really violate, the dependency inversion principle. Okay. So just be aware that that was intentional. It wasn't like I was saying, oops, I just, kind of glossed over that and said, yeah, I'm not doing dependency inversion. I am doing dependency inversion, but this would be outside of that scope. And we can talk more about that later, but I just want to point that out before we go on. Okay, so let's get back to how do we test these three things. We're going to start off with, well, it seemed like the easy one, but I'll tell you what, all three of these, pretty much the same thing. Okay, so let's deal with load people first. We'll start, and I just like to do this. Let's copy and paste. And let's actually, for now, we're going to turn it into a fact. If we want, later we can change it back to a theory, but a fact just makes it easier because we don't have to pass in data and figure that out yet. And let's look at the name of it. It should be load people underscore valid call or something like that. Okay. Naming's hard, especially on unit tests. What do you name it? Especially when you have like these theories where multiple things can be different. So they can be challenging to get right or get right enough. Okay. So let's wipe out all the code inside here and throw a new not implemented exception. Just so we have something on the books for a test. And notice right away when I save that, it goes, oh, you got a failing test, which is one of the nice things about live unit tests. It right away gives me feedback and says, yep, that's not right. So let's make it right. But first, we have to set up our mocking. Because if we look back over at person processor, it uses the underscore database, which we know is that, let's kind of hide these or trim them down a little bit. It's the s.o.l.i.d data access instance that we're passing in at the constructor. So we're using that and using the load data method. And it's of type person model. We're passing in the SQL string. So back over here, we had this passing in of null. Well, that's not going to work because we're actually trying to call the load data method. So we actually have to have an instance of our interface s.o.l.i.d data access. And this is where mocking comes in. So let's right click on references for our mock demo test. So right click on references and say manage NuGet package. We're going to browse for MOQ. This is a type of mocking framework called mock. And yes, that's a great name for a mocking framework, mock. So let's install that. I'm going to install a 4.9 version, which is the latest stable version. We'll install that. It's going to gather dependencies and install the package. We're going to accept the license agreement. And it's bringing some other packages that it needs. Before we go out of here, though, I'm also going to grab this autofac.extras.mock. And what this is an extension for autofac that deals with auto mocking of dependencies or of mock dependencies. And since we're using autofac as our dependency injection system, we're going to use autofac.extras.mock. We'll accept those terms as well. And now if we see the installed items, we have a number of installed items. And if we go to updates, we'll see we have some updates to do. Let's go ahead and update all of these. We don't have to. And in fact, there's that value tuple that it brought in. That's probably because of one of our dependencies. And you know what? I'm going to, yes, go ahead and say update all. I like to have my dependencies all updated before I take an application into production. Because when I do, take my application into production, then I might have a problem continuing to do updates. I want to make sure I test out early and often that the latest updates work for me, so that when I go into production, I don't have to go, okay, now I have to, check everything. Check at the beginning. Before you deploy, try and update everything to the latest. It gets a whole lot harder once you got active code on a server somewhere. So let's just do a latest update. I'm going to build the solution. Make sure everything builds fine. And it seems to have succeeded. My error list is empty. That's good. So now we're ready to get started with mocking. So the first thing we do is we create a using statement. Now, a using statement is different here than it is at the top. This using up here is a shortcut. And so instead of saying, let's say system, instead of saying system.console.writeLine, we just say console.writeLine because we have a using system up here. It's a shortcut. That's a different using statement than down here. This using statement is actually using an interface called iDisposable. Anything in here that gets declared inside this parens has to be of type iDisposable. And the reason why is because at the end of these curly braces, it's going to properly dispose of that resource. It's kind of nice. It's a way to make sure that we clean up after ourselves. Let's say var mock, M-O-C-K, not M-O-Q, equals AutoMock. We'll do a control dot there to add a using statement. AutoMock.GetLoose. Now there's some debate here. And so let's talk about that. The GetLoose versus GetStrict. The difference is hard to understand when you're first starting out. Let's put it that way. But the difference is that we're going to test to see if a method is called. With GetLoose, if the method is called, we're good. However, with GetStrict, what it's going to do is say, if that method is called, cool, but also no other method can be called. So it checks both sides of it. This one was called, and these other ones were not. And so with GetLoose, it doesn't check the not side of things. That way we can test parts of a method or test certain functionality of a method without making it very brittle. Because with GetStrict, it can be kind of brittle, where if we make one little change, it breaks half our unit tests. We don't want that to start off with. Maybe down the road, you change to GetStrict. But for now, GetLoose will get you started, and it's easier to understand what's going on. So what this has done is set up this variable called mock. And this mock is an AutoMock. And what that is a framework for creating fake items. Let's just start off by actually creating one. So I'm going to say mock.mock. And we're going to mock the s.o.l.i.d data access interface. Okay, so what we're going to do is whenever you need an s.o.l.i.d data access, this version is going to be passed in instead of the real version. So it kind of hooks into AutoFac, and so AutoFac goes to wire things up. It goes, oops, I can grab that one instead. So let's do it next is a setup. So what the setup does is it sets up one or more methods for us. And this is actually going to be an action where you pass in basically a method. So we're going to say x equals greater than for the arrow, and x dot, and notice how we have some methods here. Beyond the standard ones, we have load data, save data, and update data. Sound familiar? Well, it's looking at the interface and saying, what methods do you have? and it has these three methods. And so now we can set up to say, okay, this method, here's what it's going to do. So we're going to look at the load data method. And it says, okay, what do you want to pass in for the t, or what is going to be passed in for the t? Well, in this case, it is the person model. How do I know that? Well, because right here we pass in the person model. And the reason why we're doing this way is because we can actually set up different setups for load data for different models if we wanted to. But in this case, we're just going to do the one because that's all we have. And it says, okay, what's a SQL string that's getting passed in? Well, we know the SQL string is the select star from person. So we're actually going to paste that in there. Okay, so that's what we expect is for it to say select star from person. So now this method, load data, is set up so it's going to listen for the call. And if this call is made, it's going to use this mocked version instead. But that doesn't really help us yet, because what we're really interested in is the data coming back. And so what we need to do is say dot returns. What that's going to return is a list of person model. Okay, so that's what it returns. And so what we're going to do is pretend like this method actually returns that list of person model. Now, maybe a little bit lost at this point. Don't worry. Finish out the demo. I'll come back around and explain it again. But I want to show you first what it's doing. I'll talk you through it. If you have to, rewind and watch it again afterwards. It takes a few times to get mocking. But once you do, and once you start using it, and that's the important part, once you start using it, you'll see it's not really that difficult in most cases. It's more just a little quirky. Okay? And really what's happening here is we're doing some of the job that usually goes on behind the scenes of dependency injection. But instead we're doing it manually. So it's a little bit quirky. But don't worry. Now, what we have here is a return statement, but we have to return something. We have to return a list of person model. Well, what do we do with that list? How do we get that list? Well, we actually create it. So I'm going to create a private method. Private list of person model. Get sample people. And we're going to say, oops, private void. No, private list of people. Why is this yelling at me? There we go. I didn't have my using statement didn't have a generic in there, right there. Didn't have a using statement. So control dot fixed it for me. We're good to go. So a list of person model output equals new list of person model. We'll say new person model, and its first name equals Tim, last name equals Corey. And really these models don't have to be full featured. So for right now, I'm just going to do this. I'm going to create first and last name. That's it. And we'll say, that's my wife, my one son, and my other son. Okay, so there we go. There's 4 people. It's my whole family. And now we just return output. So this method now just returns a list of people. So we're going to call this method inside here. So now we've mocked out the load data method. When it's called with this parameter, we're going to return back this list, which is actually this list down here, this list of 4 people. So that mocks that method out. Now we can actually use it. So let's go ahead and use it. To do that, come down here and say mock.create. This is we're going to create a person, oops, not person model, person processor. So CLS, or if it's a controller, in your API or something like that, it'd be CTRL maybe, or you just call it the, whatever you want to designate for the class that you're testing. In this case, I'm going to call it CLS. So what happens is it uses the mock to create the person processor class. So it's going to go to person processor, and it's going to run AutoMock, but whenever it asks for s.o.l.i.d data access, it's not going to give it SQLite data access. It's going to give it our mocked version, which has just this one method wired up. And that's the important point here. We didn't have to wire all three methods up, just the one that this method is going to use. So person processor just calls one method, load data. Therefore, that's all we care about. We don't care about save data or update data. Not yet. So let's come back over here, and now we have our class to use. So we can say, let's do var expected equals get sample people, and now var actual equals CLS dot load people. So my expected goes down to this get sample people list, or this method, and which generates the 4 people. And it's expecting the same list and expected as if we call the class load people and we get the actual in that list. So it seems like we're not really doing a whole lot here. We're just comparing, we're going to compare the list we created here to the list that we created here. Doesn't seem like we're doing a whole lot, right? Well, actually we are. And so let's get into that. So let's start with our asserts. Assert.true actual does not equal null. That's important, because if the load people method fails, then we have a problem. Let's get rid of our throw exception. And notice green check marks, kind of cool. Now let's test passes, because actual actually returned a value, but we're not done yet. Assert dot equal expected dot count actual dot count. Let's make sure that the number of records returned are the same. Why would they be different? Well, what if in here we're doing some kind of modification? Now, this is a very simple method. We're going to change it in just a minute. But for now, we're just testing that it actually calls select star from person, and that it calls a load data method, and it returns the values that it was given. That's all we're testing. Now, what were to happen if we were said from persons? Check that out. We just got a failing test. Why is that? Well, we checked to make sure that the parameter going into load data was select star from person, not persons. We changed that SQL statement. It breaks our call. Is that okay? Yes, that's perfect. Because what we're testing is that we're truly making this call the way we expected it to. If we decide that that's okay, we can come back over here and change our unit test. But it's not okay. Someone made a mistake. Someone, made the cursor in the wrong spot, and they hit S and then realized it's the wrong spot and they put it somewhere else. They didn't actually take away the S. It broke a unit test because it's not what we expected. We changed that, and all of a sudden now our test is passing. So that's a good thing. Next, let's look at what happens if we refactor this method. Now, unit tests really help us in the refactoring phase because we can feel confident making changes inside this method if it's properly tested. Because anytime I make a change, those tests we run against the method, as long as the output stays the same, then it should be fine. So let's do this. Let's grab that list. var output equals, let's grab this right here and say return output, which so far so good. I refactored and putting this into a variable first. But now let's say we said, we're gonna make some changes here. For each item in output, if item.firstName equals Tim, then, double equals. Then we need to make sure that, let's just make a change here. Item.firstName equals Timothy. Okay. Now the unit test passes because we're not actually checking that data. So how do we do that? Because that's not what we want. We're making a modification to our code. See down here, Tim has been changed to Timothy. Well, we can't just say assert.equals equal expected and actual. Can't do that. That's going to break. Now, if you say, well, if you comment this out, it won't break anymore. It's not true. Okay? Watch it again. Still broken. The reason why is because we're trying to compare two objects. And you can't really compare objects by saying, are they two equal? You need to check their values and do a value comparison. So instead of this, what we could do is do a for each. Actually, let's make it a for. No, we don't do for, but because we know the counts are the same, we can do a comparison this way because they should be in the same order even. And actually checking the order is important. So, expected.count. So we're going to do assert.equal expected position I dot first name actual at position I dot first name. So that's a comparison of first name. Notice we have an error right away. If we comment this out, we're all good. See the difference right there? Just by checking the first names for each item are the same, we found that difference. Last name, last name. Okay, so we're all good now, but as soon as you make this refactoring, we can see that, nope, it broke something because we're making a modification to our data that we weren't expecting in our test. Again, the question comes back, is that okay or not? What this is doing is it allowing us to test everything that happens in this method. If changing data is okay, then we check for that. But in this case, we didn't want them to change data. We wanted to just pass it back, in which case it errors out our test. So that just kind of demonstrates that we're thoroughly testing this method. Now, what we're not testing is the actual data access, because that's outside the scope of this particular unit. This unit is just about loading people, which just makes a call, gets the data, returns it. That's all it does. And so we're testing for those simple things. If we're going to do extra stuff, cool. Then we'll test for that as well. But now we've removed the dependency on the database being involved in this process. It's not involved anymore. We're pretending like it is with our mock, but we're not actually getting the database involved. So let's go the opposite direction and test out what happens if we save a person or update a person. Let's come back over here. I'm actually going to grab this test and copy and paste it because it's got a lot of the same code that we need. And so it's going to save people method. So instead of load data, we're going to say save data. And it's going to not be a generic, so we can take away this person model. And it's not going to return anything. Let's get rid of that. And let's look at what it's taking in. It's taking in a person model object. So let's do this. And this is where I kind of reuse these methods. Let's take in let's call this get sample people. So we're going to say var person equals get sample people first. Oops, not first. Just give me the first one right like that. Okay, so now we're getting the first person back from this method call. So we're using it again in a different way. So instead of save data, we're going to have this person here. Instead of this text right here, we'll pass this in, the person, which actually it takes in the person and also the SQL statement, which let's grab the whole SQL statement. In fact, let's grab the whole definition. And you might ask yourself, why are we just going to copy and paste and compare? Well, the reason is because, first of all, it protects us from that typing. Actually, for where you type an extra letter and break the SQL statement but don't notice it. Well, this checks for that. And it also allows us then to make sure that this is the method that was called correctly. We weren't passing in a blank SQL statement or a different one that's somehow getting overloaded or something like that. And these are simple methods, but we're going to kind of bring out some of the more advanced topics by calling them that. So we have it set up, and that's cool. But here's the problem. And that's going to pass because nothing's actually happening. But that's kind of the thing, is save person returns a void. So how do you test a method to make sure it actually worked? To make sure it did what it said it was going to do? In this case, very, very simple, is just going to save the data. How do we test to make sure that's going to work? Well, we have the option of saying, oops, not on here. Let's go back over here. Let's create our CLS. So var CLS equals mock.create. And it's the same thing. It's going to be our person processor. We're going to say CLS dot save person and pass in our same person object. And now we're going to make sure by saying mock of s.o.l.i.d data access dot verify. So what we've done is we have created our class instance of person processor, which we already have mock for s.o.l.i.d data access, which just has our call here to save data. And then we actually called that. But since it's returning void, we couldn't really capture any data coming back to make sure it worked. So then what we did is we said, okay, for the mock of s.o.l.i.d data access, verify that We'll say x and the fat arrow or equals and greater than x dot save data person, comma, SQL was called times dot exactly once. And this is where we have to bring in our using statement for mock. So now I can get rid of that code. And so what this code does is it verifies that this method call, the save data method call inside of our s.o.l.i.d data access interface, was called exactly once. Now, if I said exactly twice, it's going to say, nope, that's not right. It was only called once. And so what that verifies for us is that we actually called this save data method once. And that's where that loose versus strict is coming in. And so with loose, I'm just saying, you know what? And actually loose and strict would work the same way in this instance. So I'm just verifying that this method is called once and only once. That way, if I had some kind of weird loop happening in here, it would catch that. So what if I said for I equals 1, I is less than 10, and then I make this call inside there. And it says, nope, that's no good. Because now you call that 11 times, not one time. And if I were to check for 11 times, it's going to go, yeah, you're good. You're expecting to call 11 times? Sure, you did. But this catches the fact that I called it more times than I was expecting. So that's how you test a void method. You test to make sure that it does whatever expected action you are having it do the number of times you expected it to happen, or that it happened at least once. And you can do that. I'm calling it exact here, but there's other options you can go with. At least once, at most once, between, never. So there's a whole list of options here you can play around with to make sure that certain methods are called or aren't called depending on what you're looking for. Now, this method's not really doing a whole lot of interesting stuff right now. And so it's not really showing off the power necessarily, but what it's showing off is how to do things like verify that a method was called. But let's make it be a little cooler, I guess you could say. So let's start off by saying this is actually going to be new person model. And we're going to give a full ID equals 1, first name equals Tim, last name equals Corey, and the height in inches equals 80. All right, there we go. So now there is the full person object, which just works because whether we get it from down here or whether we create it up here, it doesn't really matter. But let's just say that now what's going to happen is our method is going to modify the SQL string. So instead of it saying at first name, it'll actually say Tim. We'll just put the actual value, not the quotes around it, which would actually break the call. But let's just say it's going to do this. It's going to replace these items with their value whenever you pass in. And this is driving me a little bit nuts. I'm going to put the quotes in. Sorry. It's just one of those things. I hate writing bad SQL. Now, this is bad in a different way. If you actually have a method replacing your parameters, then you're opening yourself up for SQL injection attacks. So please don't do this. What I'm going to do here, please don't do this actual work in a real application because that would make your application more vulnerable. But in this case, I'm doing it to show you how to test for something like this. All right, so this is the resulting value, which I expect if I'm passing in this value. But right now it's saying, nope, that's not true because it says at first name, at last name, and all the rest. So now we have a failing test. We can actually write some code here where we say, let's say SQL equals SQL.replace. And we'll start off with at first name with, it's actually strings, not chars. And it's going to be let's make this a string builder or the string interpolation. The single quote and then person.first name and single quote. And there we go. There's our first replacement. And we'll have two more. We'll have last name is last name, height in inches is height in inches. And hopefully that should all work. And it doesn't. It still says, you know what? It's still not the way we expected it to be. And that's because height in inches shouldn't be inside single quotes. But notice how it caught that. If we take that off, it should be this, which works. And it does. Notice how we're getting green check marks now. So we're checking to make sure that this method is called just once and that this SQL string has been built correctly. And it has. So that is how you can use mocking to replace your data access code or any other code that has to rely on an external something. You can mock it instead in order to not have to actually make those calls. It gives you the controlled environment you need and allows this test to run as many times as you want. Just in making these edits, I've run these tests probably 15, 20 times. That's okay, because it's not actually changing data. In fact, if I were to start this up, and let's do that, let's call load people. Nobody there. Even though I've been calling the load people method and the save person method multiple times. So it still does work the way we expect it to. It's not changing our database, and yet it's testing to make sure things are working as intended. So that's really all there is to mocking. Start off with your using statement for AutoMock.GetLoose, and then use this mock to actually build out your interface calls and create the hard code or the real, the real fake method that you can then control and then either test to make sure that method is called or test the return back that you expect versus what actually gets returned when you call that method. Again, mocking out that piece of it. So that's really all there is. Like I said, I know it's a little complicated at first. And yes, this is a more advanced topic. This is not for day one C# developers. If you are in your first 3 months of learning C#, it's probably a good idea to put this video on a shelf somewhere, archive it, come back to it after you have mastered things like instantiation and interfaces and some other things like that. Basic unit testing, start there. But once you're at the point where you've created some basic unit tests and you're like, man, I need to get rid of this dependency on my database so I can test things, this is how you do it. So maybe just archive this video or like I said, bookmark this video and come back to it when you next have to create a mock. Because the first, 20 times you do it, you're going to have to refer back to something else or some documentation because of things like this verify. That I did in this video, I almost always do it. I try and put my verify up here. Wrong spot for it because they haven't actually called it yet. So that call right there has to be made before I verify that it was made. Makes sense. So that's kind of stuff that I forget unless I look back over it. So even though I've created these a ton of times, coming back over them, looking at an example, something like that is really helpful. Because you're just not going to create these every day. These are going to be once in a while things. Now, before we go, there's one other thing I want to point out before we're done. And that is, I didn't create any tests for this. This is my data access code. Now, just so you know, you might want to steal this code. This is actually really good code. This is code that I use almost every day. Sorry, I'm not trying to toot my own horn, but this is code that I've kind of condensed and boiled down over time to the point where it really works really well. But this code right here, very small little method. What it's doing is connecting to s.o.l.i.d, and it's either doing a query or it is executing a query. That's it. And the calling a query returns a to list. That's all these things do. I'm not going to test these. And you may say, oh, for 100% test coverage, I'm not concerned about 100% test coverage. And this is where a little bit of the battle can come in over tester and development and all the rest. But here's the reality. I don't test to make sure that Dapper works. And this is what this is Dapper. I don't test to make sure Dapper works. Do you know why? Because Dapper tests to make sure Dapper works. So those are the kind of things that I'm not going to worry about, especially not in unit tests. Maybe in integration testing, which is a larger hole, or even further up the chain. You do very few of those. But for unit testing, I'm not going to test somebody else's work. Just like I'm not going to test to make sure that date time gives me a valid date time. Microsoft has tested that thing like crazy. I can rely on date time to give me a date time. That's just how it is. So there's some things you don't have to test. And this little bit of code is one of them. Even writing a test for this, there's not going to be a whole lot I'm going to glean out of it. Did it make the call? Yes. Well, but that's all it's doing anyways, is making that call. So we don't really have to worry about this lowest level stuff. But one level up, where we're calling like this person processor is doing something, that's where I make the test. That's where I test out my code, essentially. Not Dapper code, my code. I test that to make sure my code is working as I intended it to, so that if it ever changes, for example, if I go, you know what, I'm going to put a D at the end of SQL here, and it didn't work, so I'll put my cursor there, and there you go. And I forget that I actually put named down here. Look at that, it broke my test. So I test my code, not somebody else's. And that's what this does. Now, we didn't test update person. I could do that. The reality is it's pretty much the same thing as my save people. But that's it. That's mocking. You just have to add in your test project, in references, for NuGet packages, you're going to look for MOQ, install mock, and also AutoFac.extras.mock. And that's if you're using AutoFac for dependency injection. Once you do, you create your using statement to start up mock, which is going to handle working with dependency injection, and it's going to handle the creation of those new mocked instances. You actually create your mock for whatever that you want to extract out and not use the real item for. And then you either verify that it worked, or you check the return value and make sure those return values match. Okay, that's what there is to mocking. At the heart of it, it's not that complicated once you've used it a few times. And this is where, again, I come back to my premise that whenever you are learning something new, you should create 3 to 5 test projects, separate projects, not the same project. 3 to 5 full projects that are just as simple as can be conceived. So nothing real world, just simple stuff, not even this complicated. I create a whole console UI. You don't have to do that. Just create a little library with a couple of interfaces, a couple of methods in a couple of classes. That's about it. It doesn't have to do anything real. Just create something and test it out. Make sure you understand how mocking works in a test environment first. Don't try and put this in real production code. Do that 3 to 5 times. For mocking, I'd recommend 5 times because it is a little bit more complicated, a little more tricky than an if statement. Okay, it's a little more higher level than that. So make 5 projects. Just try them out. Try a little different thing every time. Start with the simplest thing and kind of work your way out. And that hands-on experience of doing that those 5 times will help make it easier. You'll start to get the feel for the different pieces you put in, because what's going to happen is the first time you'll probably forget something and you go, wait, what was happening? And you go back to the video and watch it again and you go, oh, okay, I should have said get loose instead of get strict. Or, okay, that's how I do the return, or how it returns data. And so the first time you're going to do that, maybe the second time you're going to forget something else. By the third time, fourth time, you're probably getting the pattern down. You don't have to watch the video in order to build something out. By the 5th time, it's just like, why am I doing this? It's so simple. I got it. That's good. Get to that point. If it takes you 10 projects, do it. This is how you learn, by actually doing it. Don't just watch, actually do it. Okay, sorry. I'm getting off my soapbox now. I hope you enjoyed the video. If you have any questions, post them down below in the comments. I'll try to get to as many as possible. It's kind of hard to answer really technical questions in the comments, but I'll give it my best shot. And if you do have a technical question, try and make sure that you've checked out the video first. That's one of those things that's pretty common, is you missed something that was in the video. So just check the video out first before you post that question. Okay? Thanks so much. If you like this, hit the like button. I appreciate it, and I'll see you next week.